only time, and so I've been in Wisconsin for 30 years. I actually have some familiarity with this country because I spent 10 years in Amarillo, Texas, working with irrigation and alfalfa, so on. But the only time in 40 years that I've ever seen the front rows fill up was once that the staff at A&M would get together down in College Station. There was about 1,000 of us, so it was a huge auditorium, and it was always like here, the first 20 rows were empty, and then way on up into the clouds where I sat, and everybody else. Except, one time, word got out that Cotton Incorporated was going to have a style show after the break, and there's going to be women in swimsuits. It's the only time in 40 years the front rows have ever filled up. But anyway, let's go down and talk about a few things about improved digestibility and quality. And what I'm going to try to do is start with a little bit of a background on the cell wall. I was listening to y'all this morning. You hear a lot about lignin now. You hear a number of other things going on, and some of you are more or less familiar with it. So what I'd like to have you end up with is kind of a layman's understanding of lignin and some of the changes that we're putting into alfalfa. But the first thing that I want to say, and I was really impressed with the mention about steamers. I'll tell you, I'm really, I shouldn't put it this way, but I'm warming up to steamers. I think that there's a lot of places where they're a very good tool. But we did a study on 4 different rake types. The old parallel bar rakes, some of you recognize, the wheel rakes, the rotary rakes, and mergers. We each rake hay with 4 different types of rakes. We were looking at ash content in it. We did it on 2 cuttings in Minnesota, in Wisconsin, and Pennsylvania. And I'm not going to present all that data. Let's see, I think I must have. But the thing that I think is important is when we look at all of those were 600 samples that we collected from all those sites, leaf percentage accounted for 70% of the difference in forage quality. And that comes back to your steamer issue. If you're losing leaves, you're not just losing dry matter, you're losing quality. 70%. So everything that you do ought to be how to keep those leaves. All right, let's go on then. Let's talk a little bit about lignin. Lignin is the second most abundant biological compound on Earth. What's the first most abundant biological compound? What? No. Carbon. Well, in other words, it's a carbon compound, but what does the carbon make?
Sugar.
My hearing is
Sugar.
What?
Sugar.
Sugar? Actually, no, surprisingly. Cellulose, yeah. The paper that you got in front of you. Cellulose is the most abundant organic compound. Lignin is second. Now cellulose, the reason I hesitate a little because it's a chain of sugar units, but if you just look at the sugar compounds per se, like a plant for example, is maybe 3 to 5% sugar and maybe 30 or 40% cellulose. So big difference in the amount. But at any rate, second most abundant compound. Let's think a little bit about carbohydrates in plants, and those would be compounds that contain carbon. In other words, almost everything except the protein and a few fats. And we have the soluble, the starches and the sugars that you mentioned. And then we have the cell wall with pectin, and then with NDF, which includes hemicellulose, cellulose, and lignin. So there's 2 basic differences between plant cells and animal cells. One is, of course, plant cells have chloroplasts and fixed nitrogen, but the real big difference I want to focus on right now is that plant cells have a cell wall. And it grows in 2 parts. We talk about the primary wall, which is when a young tissue is formed, it puts out a wall. That wall is somewhat flexible. It allows the cells to grow, it allows them to change shape, but there's no lignin in it. And this is why, when you look at like the tops of plants, or the very young portions of plants, they're very highly digestible. There's no lignin in it. But if you let that age a little bit, then that secondary wall forms around the outside, and that's what gives the plant the final rigidity And at that point, that cell won't change shape or size anymore, but that's where the lignin is, in this secondary cell wall. So let's just talk about the components. Cellulose we talked about is a chain of glucose units. Now we say D-glucose because starch is also a chain of glucose units, but the bonds are different. Starch we can break down in our stomach, cellulose we can't, just because of the bond types. And of course that's why ruminants are so important, because they have microbes that can break down cellulose. And so it's just a long series of straight chain fibers, and that's why it's so nice for making paper and other things like that we do. Pectin is also a portion of the cell wall. It's usually that outer layer there. It's what makes the cells stick together. Pectin we should all be familiar with. Maybe not so much anymore, but us old-timers like me, you know, we used to make jelly at home and some of those kinds of things, and you put pectin in it to stiffen it. Pectin is basically a sugar acid, and it's water-soluble, and in the presence of acid and sugar, it solidifies, so it makes a jelly-type compound. It's very digestible. Hemicellulose is any kinds of several sugars, random branch shapes. It's slowly digestible. So we have those carbohydrates. Now, then we have lignin in that primary cell wall, and lignin has a ring in it, and it is composed of 3 different components. Now, one of the things I want to stress with you today is it's not just the amount of lignin that counts, it's where it's located, and it's the kind of lignin that you have that's important. So, for example, if you're making cement, the proportion of sand to concrete has a big influence on that final product, doesn't it? And it's the same thing here. The proportion of these 3 compounds has quite a bit of difference in the way that lignin operates. Now let's think about that. So lignin is valuable first. It provides strength to plants. It allows the vascular system to pull up water. You know, if you rolled up that sheet of paper in front of you and stuck it in their water cup and tried to suck up water, it wouldn't work too well, would it? It's going to leak air in, and the water's going to wet it, and the water leaks out. But because the stems of plants have lignin in it, it seals them tight so that they can transport water from the root to the leaves without it leaking out along the way. It's really important. It sequesters carbon in vegetation, and is one of the most slowly decomposing units of dead vegetation. In fact, this is really why soils have organic matter. If we didn't have lignin, it'd all break down very quickly, and there'd never be any organic matter there. But we did some study down at Amarillo. We took different kinds of residue, and we buried some of it for 5 to 10 years in sacks, porous, and after 5 and 10 years, we still had residue left. So you could add organic matter and have it build up, and of course organic matter is good in all of our soils. So, but without lignin, we wouldn't have much organic matter because it breaks down too fast. Now lignin then is these 3 components. Now, let's just think a little bit about this. In softwoods, firs and stuff like that, the primary component is coniferol, and we have less of the other 3. In hardwoods, the primary component, we have coniferol and sinaprol, and less of the cumarol. Now, think about that. The major difference between a fir and an oak is not the amount of lignin, it's the kind of lignin. Anybody do any woodworking? You all appreciate an oak board versus a pine board? Okay, well just think that's the difference in lignin. Grasses our annual plants are primarily the cumarol lignin. So different species have different kinds of lignin. And that is why grasses digest differently in animals than alfalfa does, because we have a different type of lignin in there. Now, alfalfa then is composed principally of coniferol. So that's most like which of the 3 groups I just talked about? Which one? See who was paying attention. What? Gymnosperms. Gymnosperms. Well, yeah, that's a fancy word. Softwoods. Yeah, that's right. So alfalfa has lignin like a softwood, not like a grass, and not like a hardwood. Okay? So one of the things, that I've asked is different companies have talked about the reduced lignin product. So just because we got 1% lignin, is that important or not? Well, we can only tell by doing a digestibility trial, really, because it could be that it went down a little bit, but it changed a component that didn't affect digestibility. Or it could be that we had a huge change in digestibility. So we have to monitor those things independently, is what I'm saying. All right. So when we look at the genetically modified low lignin, they went through and basically knocked out every gene. And what we're looking at is that they ended up that this is the gene that we chose to block or reduce, and this one. And it's kind of interesting. Any of you ever grown in brown big rib corn down here? I'm so old that I was involved in the original establishment of brown big rib corn 40 years ago. And we put it in sorghum then too. And it's really a good product in sorghum. I think better than in corn because it stands better. But, so, by knocking this gene down, we got our brown midrib corn. We knocked the same gene out of alfalfa, and guess what? It didn't stand up, just like corn doesn't stand up. And so we went to this one instead, and we were able to make some changes and then have lignin that stands. The other thing to keep in mind as we're looking at this is what lignin basically does is it wraps around this. So this would be the cellulose, this green, and then this squiggly stuff is meant to be the hemicelluloses. But lignin kind of just wraps around the cellulose. So it's not just that it isn't digestible itself, it's that it blocks the microbes in the rumen from getting to the cellulose, and then they can't digest the cellulose because they can't get up to it. So lignin not only is undigestible itself, but reduces the digestibility stuff around it. Now, we have done a number of trials with the reduced lignin. And I was listening to the discussion this morning, and I really think that the benefit of reduced lignin is if we can delay harvest a little bit and or have a wider harvest window. And because in our trials, what we did was we harvested it 5 times, and this is the yield per plot, and what you can see is obviously the longer we wait, the more the yield goes up, right? Our studies we did studies in Idaho and Wisconsin and Maryland, and what we found was that around harvest time, alfalfa is growing 150 to 200 pounds per acre per day. 150 to 200 pounds per acre per day. Okay? And it looks like with this GM alfalfa, just to give you a number then, we can delay harvest 5 to 7 days and have the same quality. If we can do that, we're going to increase our yield 1/2 ton per cutting. That's a big deal, I think. and so that's the kind of thing that I'm looking at with that. And then because we're not harvesting so long, a number of you said 28 days, which is for dairy, and I agree it's important, but that's putting a lot of stress on the plant. What do you want?
Just a quick halftime. If anybody has a maroon Dodge 3/4 ton, you left your lights out. There we go. See, I knew I'd find him.
Yeah. So anyway, keep that number in mind that
and you say 28 days is tough on the plant. Explain that. How, from a plant standpoint, explain how the 28-day or less affects that plant itself. I know you're dealing with the carbohydrates to get the roots back into, to build up its energy source, but everybody always talks about that. You read about it all the time. And how does that truly affect that plant?
Okay, so that's actually a very good question. So 28 days is something we can use on a calendar, but the principle goes back to 2 things that I was talking about. One is the longer you wait, the more lignin you get, and so less it's digestible. But the other is the longer you wait, the more stem percentage you have. And remember I showed you that first graph, 70%? So as we go beyond 28 days, we basically get more stem, so the quality goes down, and we get it more lignified, so the quality goes down. What we have found over the years, and of course it doesn't work on first cutting, but on second and third, for the most part then, if we cut every 28 days, then we're actually at about 28 inches, and that is generally in that 150 relative 4-inch quality range. It's actually about 160 or 70, and when you harvest it, you get 150 in the bale. Okay? Now, the same principle is true. I heard some of you aren't controlling insects. That's why some of your stands are going to be short over summer here. Okay, but on first cutting, our recommendation be to cut it 28 inches for dairy. Because if you let it get longer, you have more stem. Stem is low in quality, and so the quality of the overall hay goes down. If you're harvesting, those of you for beef cattle, 32 inches. I don't care whether it's flowering or not on first cutting. Cut at that stage. Now, again, the quality gets lower as you wait longer. But the other thing, too, is a lot of times, and I don't think it's quite as bad here as it is a little further north, but sometimes alfalfa doesn't quite flower normally on first cutting. And you wait and it gets real tall and then it lodges. Well, just don't ever let it get tall. Cut it at 28 or 32 inches, whether you want it for dairy or beef. But whether it's flowered or not, I don't care.
Well, you say if you take that 28, if you take it every 25, 28 days, it's tough on the plant.
Yes.
But why is it tough on the plant? What, taking it at that stage with that plant, what is it, what's happening with that plant that makes it tough on that plant?
Okay, again, that's another very good question. So the principle is that when alfalfa starts growing, it uses up protein and carbohydrates from the root. When it gets up to about 6 or 8 inches, then it's got enough leaf area that it quits taking it from the root. When it gets up to 10 or 12, it starts putting it back. If you let it go to full flower, it puts a whole bunch back. But if you harvest earlier than that, it hasn't had its chance to put as much carbohydrate back in the root. And what you see, if we look at carbohydrate patterns, so it starts growing in the spring and the carbohydrate levels go down. And then it regrows and puts them back. And you just see this kind of a pattern all summer, cutting at 25 days, or 20, especially 28. If you let it go to, and so our recommendation has always been to get persistence of alfalfa to let one cutting go to at least 10% bloom. And the reason is so you're going like this and you go 10%, and then you start over like that. Does that make sense? So it's just if you cut at 28, you're not putting as much carbohydrate reserves back into the root.
So if you carry it back into this low lig alfalfa, you've got 35 days instead of 28 potentially. You're adding more carbohydrates and possibly to the, your stand life.
Absolutely. So we think we're probably going to get another year out of it. I tell my farmers we should only keep stands 3 years. If you're really looking for, well, no, I think you do it. I think you can do it longer here. But I would encourage you to look at your stems per square foot. Once you fall below 55, then you're in a reduced yield range. Whether that's 1 or 6 years, I don't care. It's the stem cut that you're cutting. So when you fall below 55 stems, then it's a lower yielding stand and nothing you can do to get your yield back up. But I think some of you, and so I think those of you that are harvesting for beef, for example, can probably go 5 or 6 years because you're not stressing the plant so much. If you're harvesting every 28 days for dairy, you're stressing the plant more, and the stand isn't going to last as long. Does that make sense? Yes,
I found out, we've gone to the Roundup hay, and it keeps that grass and stuff out of it, and our stands last better.
Okay.
Because I don't know what that.
Well, it could be.
There's one thing out, the University of Nebraska has been doing research, I don't know if anymore now, on ammoniating poor quality forages. And
Yeah.
back to this lignin thing, what is that ammoniation process doing? Is it the lignin that's breaking down, or the cellulose, or?
Yeah, so first thing is don't do that for alfalfa.
I know.
But for grass, it's a good thing. We did research on that years ago. It's kind of interesting, you know, we don't like the smell of ammonia, but cattle love it. When we did ammoniated hay and we put 2 slabs side by side, the cattle would always go eat the ammoniated stuff first. They just love the ammonia.
We use ammoniated corn stalks.
Yeah, yeah, same kind of deal. So what it's doing in short, not to get,
And I don't want to get you off on something, but I just
well,
interested in.
not to get, oh, right there. So what's happening is that the hemicelluloses are binding to the celluloses. It's called an ester bond. You don't need to know any more than that. And ammonia goes and breaks those up. So it actually physically breaks the hemicellulose and the cellulose apart. So it's kind of like if you soaked your paper in water, then the fibers would loosen up and you could eventually, you know, just rub them. So it really is true and it really does work. Plus for something like corn stalks, and we've even used it in corn silage, you're adding crude protein, which can be beneficial.
I mean, cattle will just lick them to the dirt.
Oh, yeah. Well, I say, it's amazing to me, we always tend to think in human terms, oh, this smells good, or this doesn't smell good. Well, I don't care, it's what does the cow say? And, you know, for all of us, ammoniated hay smells bad, but the cows love it. And that's the perfect example why you gotta let the cow tell you, and not think what you think smells good is good. So, anyway, so ammoniated hay does break the hemicellulosic bonds and does improve digestibility. We do not recommend it for alfalfa because in alfalfa that ammonia can make some toxic compounds. It'll kill cattle sometimes. Never in grasses, but sometimes in alfalfa. So here is a study that we did then, that same study I showed you in a previous graph. These are the 2 low lignin lines, and these are the standard conventional lines. And the point would be that the low lignin lines maintain their difference in digestible fiber over time. The other thing that we're kind of watching with the GM, I don't understand why, I have no good reason for it, except we've seen in several trials that around harvest time, the digestible fiber doesn't change much in these GM products, whereas it continues to decline in the conventional lines. So if you've got, you know, we were talking about rain really determining what you do and so on. If you get a couple rainy days with the GM product, it's not as serious as with a conventional. With a conventional variety, and I'll tell you in the next talk if you're there to hear it, we would expect the digestibility of the fiber to go on 0.4 of a point per day. 0.4 per day. But in this conventional, we've got about a week spread there with 0 change. I don't know why, but I've seen it too often to think it isn't true. All right, so it is more digestible. Just going back to what I was telling you, this GM, we had looked at, is it actually more digestible? In fact, it is in both sheep and dairy. Going back to what we discussed, so here is a yield curve of alfalfa, and what we see is that alfalfa peaks out in yield and then starts to decline. When does it peak in yield? If you were to let your alfalfa go, at what stage would you get the highest yield? What?
Before it starts getting real hot.
I'm sorry.
Before it gets real hot.
Before it gets real high, yeah.
Hot.
10% bloom.
It's actually about 50% bloom, just a little bit later than you're suggesting. And it's something around that, 35 days on the average. Why does it decline after that? Because leaves start to fall off. You get leaf diseases and so on. So it would maybe still be growing more stem out towards 50 to 100. From 50% bloom to 100, it's growing more stem. It's getting more lignin. It's less digestible, but you're losing dry matter because you've got leaf loss. So if we look at forage quality then, and I'm a little bit sensitive to this. This is for dairy. We're something around 28. The bulk of you are harvesting for beef, so that's something around 32 days, 32 inches, something like that. Is that about what you're harvesting at for beef?
Yes.
Don't tell me it's whenever you can get to it. Not a good answer. Because there is a difference in quality. It makes a difference to growing animals. You know, it makes a difference to outwintering animals in weather like we've been having too, to have a little higher quality. Now, one of the things, and this comes back to the comment about delay harvest. So I did a study with 6 or 8 varieties several years ago, where I took 3 or 4 cuttings. This is at Madison, Wisconsin, 3 versus 4 cuttings, with the last one September 1. So one was on about a 28-day interval, and one was about a, whatever that works out to, 35-day interval, okay? Now, the first thing is if you cut 3 times in the same growing period versus 4, which one yields more, 3 or 4 cuts? 3, always. You know, a lot of people don't know that. I should have known. You guys are pretty on top of things, there's no question about it. So, but anyway, and what we see is that if you look at this data, 3 cut here, I got 7.5 tons, 4 cut, I got 6.5 tons. Same variety, side by side, same growing conditions. The reason that the 4 cut yields less is because it gets cut once more and has to start over an extra time, right? And then, and so that was a 17% yield increase by lengthening the period of growth. So one of the other things I always stress to people is whatever stage you're cutting at, particularly for dairy, I mean, I'm from dairy country, but the dairymen need to pay for that because it's costing you yield to harvest that high quality hay. And then, but the other thing I wanted to point out from this is we carried this into the next year, and there we had about a 25% yield difference between the 3 versus 4 cuttings. And I think that was kind of this carryover influence that we didn't get as good a yield generally, but generally speaking, because this one had been rested more in the preceding year and rebuilt those root carbohydrate levels, and we're seeing this with the low lignin, when we go to a 35-day schedule versus 28, it greens up faster in the spring. It just comes back a little bit faster because we're not putting quite so much pressure on that stand. So, again, for dairy, we've needed to cut it 28 days. I think it's economic for the dairyman, but it does reduce yield and it does shorten stand life. And we just need to, that's...
If you let it go 50% bloom and you're gonna go beef cow, if you're shooting for dairy, we've got a vicious August here, let's say, where you need to probably cut it 25 days to get your RFD level to the dairy. You just say, okay, my first 2 cuttings were great or whatever, I made dairy quality and most of it, I can afford to let one. Well, that timing of allowing that to go to 50% bloom to get the most carbohydrates down there, will that have an effect like not taking that 4th cutting, or if you continue to take that 4th cutting, because you put more carbohydrates down there? I guess that's what I'm asking. You've allowed that plant to rest one time where you're talking about there.
So when you're talking about your 4th cutting, though, you're still talking about taking it...
Taking the 4th, but in the 3rd cutting, you allowed it to go to 50% bloom to fill full of carbohydrates.
And yes, it will.
Okay.
Not 100%, but it will head you in the right direction.
Okay.
Absolutely. That's why, again, our recommendation has always been for those harvesting on 28 days for dairy to let at least 1 cutting go to 10% bloom. For you as cash hay, beef cattle, a dairyman himself would use it to feed his heifers, but he should let 1 cutting go to 10% bloom if you're harvesting on a 28-day schedule. If you're generally on a beef cattle schedule, then it doesn't make any difference.
So which one does that end up being?
I usually recommend the second last one of the year, let me put it that way. Because you want your last one, you're going to time it a little bit about by the weather and stuff like that. So if you're taking 4 cuttings here, it'd be the 3rd one. A little bit north where we're only taking 3, it'd be the 2nd one.
I think generally our place it's usually out of our control. The weather usually decides which one's gonna go.
Well, there's that too, yeah.
One won't quiver, yeah.
It almost seems it would be the first one.
Yeah.
Yeah, the reason not is because if you're looking, so you start on first cycle, I gotta do it the other way. You start on first cycle, you draw down your carbohydrates, you put it back in, and then like I said, if you're harvesting at 28 days, you're on this kind of a pattern. Well, if you do it on your first cutting and build it way up, you're still on this pattern the rest of the season, and you'd like to do it a little bit later in the year so that you enter the winter with a little higher carbohydrate level. Because it'll regrow with the lesser amounts, but it won't survive the winter as well with the lesser amounts. Yes, sir?
So when you're trying to survive the winter, and you let it regrow 6 to 8 inches, and you're taking all those carbohydrate reserves and you put them into that plant, once you get that frost, will that reverse and those carbohydrate reserves then go back into that root? Or do
No.
you have to get more to that 12 to 18 inches before winter time to get any carbohydrates?
So the latter case, the worst way to enter the winter is to have your alfalfa grow to 6 inches and then have a killing frost. That's the worst thing you can do, because you've drawn it down, and those carbohydrates, once that top freezes, are not gonna go back into the root. So that's why we always have kind of a no harvest window in the fall. And I don't know what they say, I would imagine something like September 10th to 15th, I would think, up to, some people say a killing frost. I don't believe in that. You just want to cut late, you want to cut early enough that you can get above the 6 inches and back to 12 to 14 to put the roots back, or you want to cut so late that it isn't going to regrow and use them up.
Were you the one that did the study that 200 and some growing degree units,
Yeah.
that in the fall, not to exceed 200 and some growing degree units?
So what I did was, and there's data to support this, so in other words, in the fall, to get it started and put carbohydrates back takes about 500 growing degree days. 43 degrees instead of 50. I have to go check the numbers. I hadn't thought about this for a while. Sorry. But anyway, about 500 growing degree days, a little bit cooler temperature than the 50 that we use for corn. So 500 after your last cutting before a killing frost. The alternative is to cut so late, you don't need a killing frost, but you want less than 200 growing degree days. So what I actually did for 4 different locations in our state was I took 40 years of data records and plotted the probability of 500 and by week and the probability of 200. Because, and I bet you guys have done this too, so some expert comes out from the university like me and says you shouldn't cut after September 15th. And the first thing I was saying, I cut on the 23rd last year and it worked just fine. Well, it does, a percentage of the time. And so what I always tell people, so like our date is pretty well, at least the middle part of the state, September 1, southern part of the state about September 5th, 7th. Okay, if you wait a week, you still got a 75% probability. If you wait 2 weeks, it generally goes down to a 50% probability. So I told people, sure, you've got 2 weeks late. How lucky do you feel? And that's exactly what it boiled down to. If we knew what the weather was going to do, we could time it perfectly. Short of that, we have to work on a probability. Yes, sir?
What if you cut after it freezes, say like if you got a hard frost, or would it just be better for let the cattle graze it off?
Now, there's no problem with cutting after a hard freeze. And again, with this 200 growing degree days, let me just back up. I usually recommend trying to cut right before a hard freeze because it's pretty bad haymaking conditions after a frost usually. But a week or 2 before, you got decent haymaking sometimes. Almost never the week after. But if you get to that point and you don't want to mow it, then grazing it off is a perfectly good way of handling things. What we find is that there is some value to leaving some residue in terms of winter survival, that the stems do insulate the crown. The other thing is that they do help, collect snow. So when you got like we got out here, it doesn't make any difference whether you grazed it or not, okay? And I've got regions like that in Wisconsin. the very northern part up against Canada always gets tons of snow. So we can get California varieties to grow and survive the winter because we always have good snow cover. But down at Madison, the snow comes and goes like it does here. And so then you need a little bit more winter hardiness, and then a little bit of residue helps. Now, as we're going into the 4s and 5s, and how many of you take a late fall cutting? Okay. I generally recommend it, I think, at least for us, and you would have to think for yourself, but if you've got good soil fertility, what I see is about 80% of the time it makes no difference. So as long as you're willing to settle for 1 time in 5, it's going to hurt your stand. Well, you know, you decide. Now, you disagree?
No. I just, 1 time in 5, kind of sounds scary to me.
Well, so then you might not want to take a late fall cutting. I can understand that. But there's a lot of people, especially when we're figuring out our, you know, the shorter your stand is too, the less that bothers you. But for us, it's about a 20% probability of no effect. On the other hand, it's kind of interesting. Now, those of you that are selling can always sell more hay, so it's an issue. Those of you that are growing for your own beef cattle, there comes a point where you've got enough. And last year and this year, we had pretty good yields around. In fact, I had people calling me on the 1st of August saying, well, what would happen if I just didn't cut my alfalfa anymore? They were tired of making hay, they had their barns full, and that was all they needed. So, you know, it goes a little bit on what you can do with it and how valuable that fall cutting is to you as well. But the good news is that as we've gone to less dormant types, it's more worthwhile to take the fall cutting. And as we've improved our winter hardiness in these varieties, if you go out there and look, a lot of the varieties that are being sold will be something around that 1.5 winter survival, and that's a good number for you. It used to be that they were 2 to 3 in terms of winter survival, and then taking a late fall cutting was riskier.
How much does your history of the summer affect that? If you have longer cutting intervals in the summer,
Yeah.
how big a difference does that make compared to taking that late fall?
How much difference does it make in terms of yield or survivability? That's a really good question. I guess I don't have any numbers to answer that. Either one is a good deal. And so if you want to take a late fall cutting, have it stretched it out, would have less impact on the fall cutting, obviously. So there are trade-offs there, but I can't give you any firm numbers. That's always kind of variable too, like we know from year to year, how much you stretched and stuff like that. So anyway, the point would be if we could increase the harvest interval and get the quality we want, we can improve our persistence, we can improve our yield. And that's one reason too why those of you that are for beef should cut it 10% bloom. You don't want to cut it bud because you're taking an extra 15-20% yield discount and you can't use the energy. But if you can sell that for dairy quality or feed your dairy cows, well then it's worthwhile and you should do that. So we see with the reduced lignin, the GMO, is that we've been able to delay harvest about 7 days per cutting. And therefore we can get about, well, 7 times I told you to say 150, that's about a ½ ton extra yield per cutting in round figures. I think for a lot of us, you know, there was some talk about taking this and eliminating a cutting. For some of you, I think generally that's not going to happen. I think there are a few regions of the country where it might. But for the most part, I think what we'll end up doing is going to stretching it out and using a little bit more of the growing season. So we'll, and that again is helpful too. But like down here where you're taking 4 cuttings, and we'll have to see, we're still learning about this. My thought would be we don't want to delay first cutting a week because this stuff stands as good as a conventional, but everything goes down if you leave it an extra week in the spring, okay? So I'm thinking you're not gonna wanna do that. So then it's only stretching the following cuttings, and that's not enough to make up for going from 4 to 3 in many cases. But some regions take 5, and going from 5 to 4, I think, is a good possibility. Does that make sense? We'll see, I can be wrong on that, but I am not recommending letting first cutting go longer with it. The thing to keep in mind about lignin reduction, the question I always get is standability. Does it stand as well as conventional? And the answer is yes. We need to remember that we got a 20-30% lignin reduction. Actually, excuse me, 15 on a whole plant basis. That's the stem that's reduced that much, the 30%. But we're going from 6 down to 5, basically, in terms of the lignin. 6% down to 5 point whatever percent lignin, okay? It's important to remember again, anybody know how much lignin's in corn? It's about 3. So this goes back to the different kinds of lignin, but we got twice as much lignin as corn does, so we obviously don't need as much as we had to stand up. And so what we're looking at is it's not just I told you about the amount of lignin, I told you about the kind of lignin. The other thing though is the location of the lignin. Where is it in that stem? And so what we see, if you cut across the stem of alfalfa, you see that you have your outer cuticle, if you will, and then you have a ring of bundles inside and some pith in the middle. And that's one thing. One common misconception is that finer stemmed alfalfa is a good idea. That's completely wrong. Because with finer stemmed alfalfa, all you're doing is decreasing this pith area in the middle. And you guys know this, which cutting has the biggest stem? First. Which cutting is the highest quality?
Fourth, third or fourth.
Third or fourth?
First.
Yeah. Okay, I won't argue with fourth, but first is usually a pretty good quality cutting too, if you get it put up on time. My point would be that the biggest stem cutting generally has the highest quality, so stem size doesn't relate to the quality. In fact, what happens is we got less lignin, the microbes can get into that stem, and it being a little bit bigger helps them get in and digest it when it's in the rumen. So a small stem is not a good idea. I'm just going to go down, as we look at that, if you're going to be growing either the Alpha X variety of reduced lignin or the GM type with reduced lignin, you'll never see a lignin reduction in all likelihood. But what you should be looking for is a difference in the digestibility of the fiber. The reason being, if we look at, say, the Alpha X, they're talking about a 7 to 10% lignin reduction, forage genetics 10 to 15. If we look at actual units, this is about 0.5% less lignin to 0.7%, okay, for the Alpha X, and it's 0.7 to 1% lignin reduction. Now, something you didn't want to know is I've worked for many years with forage testing across the United States, and lignin analysis is a very difficult analysis. It is very variable. One of the things that the National Forage Testing Association does is send out check samples. And in 2013, they sent out 5 check samples. The average was 6.7% lignin. See down here, corn, a little bit below 3% lignin. All right, but when we looked at these, the standard deviation was 0.69, which means 2/3 of the time, the results from the labs were between 6.7 plus 0.69 and 6.7 minus 0.69. So you're going to be able to tell a 0.5 difference? No, can't. Now, from a research basis, we can do it because we have small plots growing side by side, and we take multiple samples and do all kinds of things. But in the field, it isn't going to show up. Look at this, in fact, the labs on this given sample, or average of 5 samples, range from 4.9 to 9.2% lignin. So they're just not going to be able to see a half or a 1% difference in the field. So the value of reduced lignin is improved forage quality, potentially a wider harvest window. And then the third thing that I would think most of us would go for would be greater tonnage, because we can let the cuttings go longer, making better use of the full growing season. You know, if you guys have been taking 4 cuttings, and you start, when did you take your first cutting here? I imagine around the 10th, 15th of May, something like that, right? Okay, and if you cut every 28 days, it's June, July, August, 10th. You got 3, 5 you can get in sometimes if you can do that. See, then I think you'll be able to go to 4 cuttings if you back off. But anyway, my point would be that oftentimes it slips, you end up about August 15th, you don't have time for another whole cutting, but if you had let some of your cuttings widen out a little bit, you could have better used that growing season, and that would have given you more tonnage. I think that's going to be the most common. Once in a while, we'll reduce the number of cuttings like this fella here. One last thing more than you wanted to know, to recognize that in terms of lignin, there is a genetic effect. We've talked about this in terms of improved varieties. We've talked about this in terms of the GMO. But we need to recognize that there's also an environmental effect. Lignin is formed from a light-activated enzyme. So, and it's infrared. So when we have a lot of light, like over summer, we get a lot of lignin, and that's why fiber digestibility generally goes down. We have less light like that in the spring. And the other thing is have you ever been around a greenhouse and seen plants grow up? They grow kind of tall and spindly. Well, the reason is because the glass shades out the infrared light, and so it doesn't make as much lignin. So the same thing can happen on a field basis if you have a whole bunch of cloudy days. But the other thing is lignin takes high temperature. And so first cutting generally is a little bit lower in lignin because you have cooler days during the spring than you do over summer. And the same thing on fourth cutting. Later in the season, you tend to have that. But the other thing is in all cases, and part of the reason I started out with this leaf percentage importance is that we're going to have to really put all these systems in good management. We're going to have to keep the leaves on the way through to make it show up. And one of the things, for example, and we just mentioned it here, is if you let alfalfa grow longer, it starts to lose leaves, doesn't it? So we might need to pay attention to that a little bit. I'm thinking some areas are going to want to put fungicide on in some cases to help hold the leaves. Maybe, maybe not. I think you need to assess it for yourself. But when we've done the headline trials, we did not see a benefit putting it on alfalfa that we were growing for dairy at 28 days. But when we had some cuttings that were delayed by rain a week, well then we saw a big benefit to the headline fungicide. So you might need to look at the package. So we need a favorable leaf environment, in other words, good sunlight. We need to have less leaf disease. And some of you are going to be in good shape because generally with the arid environment we have less leaf diseases, but irrigation kind of wipes out some of those differences. It gets humid more often in that plant canopy. And then we want to make sure that we reduce the leaf harvesting losses. So I think we get higher quality stems, but we're going to have to keep the leaves through the harvesting process. Questions or comments? Yes, sir.
Have you done any studies on bill density through low lignin? I guess when you brought up the first cutting thing being in low lignin, that's what we used to refer to as, our first cutting big square bale stacks that tend to fall over or lean. You'd lose the density in your square bale and it would kind of compact a little bit as you go. It seemed like those were always the hardest bales to pick up were some of those early cut, first cutting bales. And we've actually had customers that we sell this low lignin seed to that's one of their questions is, am I going to be able to stack them 5 high, 6 high without them falling over, I guess. Anything to say on that?
Well, I do think you are going to have to make some special efforts, but I've made some with a couple of different equipment pieces of equipment. I have increased the tension,
Okay.
but we've been able to get good bales out of it.
Okay.
I think generally speaking, we're not making any of the bales as dense as we should.
Yeah.
You know, on your dry hay, there's no reason not to have a very dense bale. In fact, the denser it is, the more you can store in any given space. And that's why they double compress what we ship abroad, because you want to get
Yeah, no, for sure.
a certain amount in a container.
So high density balers with alfalfa, and you the advocate for that and say that those would be better than produce a 2,000-pound bale and take away any oxygen out of that bale?
The short answer is yes. I think that there are, the constraint on that is what your buyer wants. A lot of the dairymen could use the 1-ton bale. Some of them want to stay with the half-ton bale just because of the size of their skid steer and some of those kinds of things. So it's a more practical thing. I haven't had any success. I've also kind of promoted the half-ton bales for horse people. Just, you know, you can peel off about a 40-pound slab without great difficulty if you can get it loaded in your storage facility. And it's cheaper, and you'd rather make that.
Your first graph you had leaf loss on all different types of rakes and mergers and everything. What did you find out?
Well, and we'll be coming out with a lot more. The first thing is, I think with an awful lot of this equipment, let's start with, if you decide something's going to work, you're probably going to make it work, okay? Some people like red equipment, and some people like green equipment, and for some people one works better, and for some people the other does. So that's the thing. But what I'm really coming back to a little bit facetiously is that there are some design considerations, but within each rake type, the way it's operated is at least as important as the design types. So for example, well, we had 3 different rotary rakes. 2 of them did better than the wheel rake and 1 did not. So we're going back and looking, there may be a little design difference. Might have been the PTO speed relative to the ground speed, you know, some of those kinds of things. The nice thing about wheel rake is that there isn't much adjustment on them except not to put too much weight on the wheels.
You were talking about ash,
Go ahead.
about ash content. The wheel rakes tend to pick up a little more dirt.
I'm hoping to hear those numbers in the next couple of weeks, so I don't know yet. My hypothesis is that they would, but again, it also depends on the kind of teeth that you have on there, and I'll say how much weight you put on the wheels. We'd like to see the minimum weight to move the hay that you have, which then, of course, the wheel rakes work nicer with drier hay, the rotary rakes work better with wetter hay. The wheel rakes don't turn heavy windrows quite as easy. And a merger works with either one. So you've got a lot of different things going on. But yes, my hypothesis is we'll have a little bit more dirt in with the wheel rake than we would. The rotary rake, if you start with a wide swath, your tines don't have to touch the ground, and that should be a benefit. But if you're not making a wide swath and you got to dig into the ground, then you won't see that ash benefit. Does that make sense? So we have some principles. We'll see what the data looks like, but I think it's going to come back to a combination of design and management both.